Our next problem. Problem having been chosen from the same book, Modern Physics by Stephen T. Thornton and Andrew Rex. As usual, we first come to its statement. Okay, in an experiment done by scattering 5.5 million electron volt alpha particles from a thin gold foil, students find that 10,000 alpha particles are scattered at an angle greater than 50 degree. Part A. How many of these alpha particles will be scattered greater than 90 degree? How many will be scattered between 70 degree and 80 degree? Dear students, actually problem is quite simple because when we will apply formula, most of the parameters will be cancelled. However, we need to find scattered fraction for four values. Okay, one value is 90 degree. If we go in a descending order, okay, 90 degree, 80 degree, 70 degree and 50 degree, and definitely we will take theta as a angle as a half theta. So in other words, now we are going to ascending orders. Okay, that is to say cot 25 degree, cot 35 degree, cot 40 degree and cot 45 degree. These four values will play basic role. Okay, anyhow, we now start our solution. Dear students, its solution, before starting its solution in a formal manner, we are going through a few snapshots which will provide a foundation for our better understanding. Okay, dear students, these first two snapshots, let us first see how many snapshots are used in this problem. Okay, one two snapshots. Oh yes, only two snapshots are included in this problem, and these two snapshots are also alternate of each other. Okay, exactly one and the same thing is being used by the other author in a slightly different manner. Okay, first snapshot says scattering impact parameter B is equal to small z capital Z over 2 capital K into 4 pi epsilon naught over B. Scattering impact parameter B is equal to small z capital Z small e square divided by 2 capital K into 4 pi epsilon naught into cot theta by 2. Okay, yes students, in this formula actually small z some in its alternate some authors in place of small z capital Z use z1 z2. Okay, similarly in this first snapshot kinetic energy is denoted by capital K, while in second snapshot it is denoted by m alpha, mass of the alpha, into v square, that is half mv square, and 2 in the denominator has been adjusted at some other place. Okay, moreover, here e square has been used in first snapshot, while in the second snapshot small q and capital Q are used. Okay, small q is included with this alpha as a subscript of small q. Okay, so E charge and small q alpha and capital Q are also charges. Moreover, in the second snapshot, in place of 1 over 4 pi epsilon naught, small k is used. Okay, small k means 1 over 4 pi epsilon naught, while capital K means half mv square kinetic energy. Okay, so scattering impact parameter B is equal to small z capital Z into E square over 2 capital K 4 pi epsilon naught into cot 1 by 2 theta. Fraction scattered at angles greater than theta. Okay, small f with greater than theta, where greater than theta sign has been used as a subscript of f, is equal to n into t into pi into b square. Okay, this is the formula, this is the expression. Okay, here n is the number of nuclei per atoms, nuclei per unit volume, t is the thickness, pi is 22 by 7, that is 3.14, and b is the impact parameter. This okay. In this second snapshot, the same philosophy has been repeated in some slightly different mode. Okay, Rutherford scattering impact parameter small b is equal to small k small q alpha, where alpha is written as a subscript of small q into capital Q over m alpha, where alpha has been written as a subscript of m, that is to say mass of the alpha particle, into v square into cot theta by 2. Scattered fraction f is equal to pi b square n t for a scattering foil with n nuclei per unit volume, and thickness t. Okay, so dear students, on the basis of this snapshot we will solve our problem. The relation between the impact parameter B and scattering angle theta for Coulomb scattering is B equal to Z1 Z2 E square over 8 pi epsilon naught capital K into cot theta by 2. Okay. Question number 1. This is the exactly same question which is included in both snapshots. Okay, now scattered fraction f for a scattering foil with n nuclei per unit volume and thickness t is given by f is equal to pi b square n t, equation number 2. Okay, then in the next step this b will be used in this, that is to say equation number 1 will be put in equation number 2, and we will get, let us see what we get by using equation number 1. In equation number 2 we have f is equal to pi n t into z1 z2 e square over 8 pi epsilon naught k into cot square theta by 2. This is equation number 3, and this is here once again, dear students, that mistake has reappeared. I ensure, I promise that if in next problem, in next video, this expression is used, this mistake will not take place, this mistake will be omitted. Okay, actually dear students, because b is insecure, so when we put the value of b, then this factor will also be insecure. Okay, z1 z2 e square over 8 pi epsilon naught into k, like cot square theta by 2, this value is also insecure. Okay, but by mistake that power 2 has been omitted. I ensure that if in next problem, in next video, this expression is repeated, copy paste version will not be able to repeat this mistake. Okay, this is equation number 3. Now dear students, using equation number 3 we find, one time we put the value with theta equal to 50, then 70, then 80, then 90. Okay, we will put 4 values of angle theta and four values of scattered fraction f will be obtained. Okay, and next four new equations will be named as equation number 4, 5, 6, 7. Okay, so equation number 4 is in which angle has been taken as 90. Okay, f 90 degree becomes equal to this is square into cot square 90 square 90 degree by 2. Similarly we put 80, similarly we put 70, similarly we put 50. Okay, dear students, you are seeing equation number 4, 5, 6, 7. These are exactly same, and the same mistake is repeating in all these four equations, that this factor is not shown in square. But even if it is in square or not square, it will be cancelled when we will divide one value by other. Anyhow, mistake is still repeating itself. Okay, f90, f90 degree, f80 degree, f70 degree, f50 degree. Okay, new four equations have come into existence. Okay, equation number 4, 5, 6, 7. This. Okay, so angle will become 45, this angle will become 40, this angle will become 35, and this angle will become 25. Okay, dear students, now we move forward. Now f90 divided by f50, f90 degree divided by f50 degree is equal to cot square 45 degree over cot square 25 degree. This becomes, actually value of cot 45 degree is 1, while degree value of cot 25 degree is 2.14. Okay, I have taken these values from online calculator. Okay, Google, you may take these values from some other source. Okay, there may be a lot of sources. Okay, however, I have used the most easily available option. Okay, so after simplifying, we will get f90 degree over f50 degree equal to 0.22. Similarly, if we in place of f90 we take f80, then this ratio becomes equal to 0.31. Okay, dear students, actually the value of cot 40 degree is 1.19 as per online calculator, and value of cot 25 degree is 2.14 as per online calculator Google. Okay, now if we take ratio between these two fractions, f70 degree and f50 degree, then its answer becomes equal to 0.45. Okay, dear students, actually the value of cot 35 degree is 1.43 as per online calculator, and value of cot 25 degree as per online calculator becomes 2.14. Okay, and hence after simplification this ratio becomes equal to 0.45. Okay, next, dear students, now we are coming to, now actual part A is starting from onward. Okay, this portion was common for both parts A and B. Okay, now we are coming towards part A. Now number of alpha particles scattered through angles greater than 90 is okay, because dear students, our once again we go to statement. Okay, alpha particles from a thin gold foil, students find that 10,000 alpha particles scattered at an angle greater than 50 degree. Okay, dear students, it means this 50 degree is common along with the remaining four values, that is 90, 80, 70. Okay, 90, 80, 70 on one side and 50 on one side. 50 will be always used. Okay, now we are coming towards part A of this problem. Okay, dear students, up to now what we have done is applicable to both part A and part B, but now we are particularly starting part A. Okay. Now, number of alpha particles scattered through angles greater than 90 is F90 over F50 degree. Okay, multiplied by 10,000, because this number is given in the statement. Okay, this becomes equal to 0.22. We have calculated this value in the previous part. Okay, let us go to see which is 0.22. 0.22. Yes, this is 0.22. Okay, F90 degree over F50 degree is equal to 0.22. Okay, we have used this value here. Okay, so part A, this 0.22 into 10,000, this becomes equal to 2200, 2200. Okay, now we are going towards part B. Okay, now number of alpha particles scattered through angles greater than 80 is F80 over F50 into 100, 10,000. This value, this is its value is 0.31. We see what, which is 0.31, 0.31, 0.31, 0. This is 0.31. Okay, f a fraction 80 degree over 50 degree is equal to 0.31. Okay, here we have taken this value 0.31. Okay, so when we will multiply 0.31 with 10,000, it will become 3,100. Now we are coming to next requirement, that is now a number of alpha particles scattered through angle greater than 70 is F70 over F50. Okay, dear students, as I have said that in every calculation 50 is involved. However, remaining three values are changing. Okay, 90, 80, 70 are changing, but 50 is comparable with every value. Okay, now number of alpha particles scattered through angles greater than 70 degree is F70 degree over F50 degree multiplied by 10,000. This becomes equal to 0.45 into 10,000 is equal to 4500, 4,500. Now see which value is 0.45, which value is 0.454, 0.45, yeah, this value 0.455. Okay, F70 degree over F50 degree is equal to 0.45. 0.45 we have used this value. Okay, 0.45. Okay, 0.45 when multiplied with 10,000 becomes equal to 4,500. This implies that number of alpha particles scattered between 70 degree and 80 degree. Okay, this is our main requirement. Alpha particles scattered between 70 degree and 80 degree. We have separately found those number in above two steps, and now we are taking difference of those two. Okay, this implies that number of alpha particles scattered between 70 degree and 80 degree is equal to 4,500 minus 3,100 is equal to 1,400. So 1,400 is our ultimate answer to this solution, is our ultimate solution to this problem. And this is the end of our video. This is the end of our problem. Till next video. Allah Hafiz.